Okay, Emily won't be here. Okay. All right, so all right, so what we're gonna do is kind of review a little bit about a power series, since this is a Wednesday. A power series with a variable x that is raised to some type of power n, so that will be a power series. So you should start with the a0 plus a1 x1 plus a2 x2 plus a3 x3, a power series x center at origin. Shaylin, Fabian, seriously? Okay. So for this particular part that we already went over, now if you're not here Wednesday, you can take a picture, but I'll explain to you really quickly. Aiden, Folk, Cookie, a lot of you are not here Wednesday. Okay.
I have notes up to and including power theory.
A power series with a variable x. So we talk about the center. A lot of people don't understand what a center means. Why do you have x minus c? And we kind of did that over the Wednesday. So let me show you. Does anybody remember what is the? Does anybody remember what is the sign but in power series?
Sign in power series. -1 to the n.
-1 to the n. Okay.
Times x to the 2n plus 1.
To the n. Times what?
X to the 2n plus 1.
X to the 2n plus 1.
Over 2n plus 1 factorial.
Of 2n plus 1. Okay, 2n plus 1.
2n plus 1.
2n plus 1 over 2n plus 1 over 2n plus 1 factorial. Good.
And initial condition for n is 0, not 1.
Yep. 2n plus 1. And this, thank you for the thing. This one is going to be 0. And this is 1. This is a 5. Let's do 5. Let's do maybe 8 like this. Okay, so that is the sign graph. But the problem is, what if I change the x to that says move at different center? So that's why we have a different center. If I have different center, let's just say if I have different center at, let's say, pi over 3 or pi over 4. So how do I do that? I change this x right here. I change the x to becomes, I'm going to put a parenthesis in front of x here. I put a parenthesis after.
You should translate the x, right?
And we can say, okay, well, we want to move the center to the right or to the left. Not just say we want to move to the right, pi over 4. So it'll be minus pi over 4. And you see that this becomes the sine of x of pi over 4. Sine of x minus pi over 4. Yes.
Do you do this like every x value? Like minus.
Yeah, so when you write out a term, it's going to be x minus pi over 4 for everything.
Okay.
So everything, so this is the same representation as sine of x minus pi over 4 because my center is at pi over 4. And we did that on Wednesday. And then, so we talk about the power series is defined as such. This power series, this is an example of power series. An example of power series, if you have -1 to the n, x to the n over n factorial, and that's going to give you 1 minus x over 1 factorial plus x squared over 2 factorial minus x cubed over 3 factorial if it's center at 0. If it's center at pi over 4, this is other function, and So this is other function that is centered differently. Now we're going to talk about this statement again. This is a very important statement. The statement says those power series center at a function of x. F of x is defined with power series with a domain of all x, such that the an x minus c to the n converge. So the domain has to be converged. If your domain is not converged, it cannot represent the function. So we say the power series can represent the function only if the series converge. If a series diverge, cannot represent the function. Okay, so that's a very, very important statement for power series. This, we're going to come back to this, talk a lot about this statement. We will. So it has to converge, because if it diverge, the function is going to go infinite. If a function goes to infinite, how do you represent the function? So it has to converge. So that's why we're going to do a thing today. It's called radius of convergence. That's something we're going to learn. How do we get there? If function diverge, it cannot represent the function. Power series diverge, cannot represent the function. Power series converge, it can be represent the function f of x. So what is a radius of convergence? We're going to say that this is the main topic today, which is the most of the time is going to be on AP exam. The radius convergence means, you know how we have this graph here? It's only stopped right here around 5, right? But we can go to infinite. If I do a lot of iteration, if I go to, let's say, 800 iteration, then it will be exactly the same. So the radius convergence here is defined as from negative infinity to positive infinity. So which is radius convergence is actually infinity. The interval convergence is actually from negative infinity to positive infinity. We're going to get to that because this one is a one example of domain is actually from negative infinity to positive infinity. Yes?
How can it be negative infinity if you're starting at 0?
Yeah, but it's just saying the power series can represent as a function if this has interval convergency of negative infinity to positive infinity. But sometimes, remember, we have dealt a function that's only effective from -1 to 1. Remember that one? Okay. And that's radius convergence of 1. Or interval convergence is -1 to 1. Only work in a special domain. Because only in that domain, this power series can converge. If any other, but so here you can plug in any x. It's always going to be converge. I'm going to show you the proof that we can plug in any x. It's going to be always converge. Actually, you're going to prove it. But we're going to teach you how to prove it. Okay? So this statement is so important, so crucial. The first couple of times I taught it, I didn't understand it. I'm going to be honest with you. So it's pretty hard. So it takes a lot of teaching to understand like what you're actually doing teaching. So the first 2 years was kind of like guinea pig. A lot of times, the student will ask me a question. I'll be like, oh, that's just the way it is. Unfortunately, I kind of get better throughout each year. So this statement is something I didn't never stress before. Okay. Huh? We can talk about that today, end of the day. Okay? So, and we start with this power series. We start with this power series, x to the n equal to 1 plus x squared plus x cubed. And the way you think about this function is, hey, this is just some type of power series. How can this function represent a function of f of x? And we talk about this. How many guys here are not here that day, Wednesday? Okay. All those skippers. So
We all got Johan that
raise your
day.
hand.
Oh, my bad.
you had a business trip? Okay.
Yeah.
All right. So that day, we have asked the class, we says, hey, what will be the function represented by this power series? 1 plus x squared plus x to the cube plus x to the fourth plus x to the fifth. And go to infinite. Which function will be that? Okay, I know you know, but I need the rest of them that who's not here to take a guess at this.
X to the power of F, right? No, never mind, never mind.
That's a good start guessing. That's fine. Okay, so those of you guys are not here that day. I want you to recognize, how do I get to the next term? How do I get from this term to next term, and this term to next term, and this term to next term? Ian, I know you know. Okay. So how do I get to the next term, Aiden? It's times x, right? So each thing is times x, right? It must means that there's something here that it times x each time, and this can represent as a function, and you're like, wait, which series that we have talked about before that is times same thing over and over and over again? Folk, do you know? Why is geometric? Common ratio is x, okay. So common ratio is x. Do you understand what is the geometric series formula?
A over 1 minus, I mean, R, sorry.
A over 1 minus r. Good. So the a1 is here is 1, right? And r in here is x, right? So this represents as geometric series is a equal to 1 minus r, and it's converged only if r is less than 1. It's converged only if r is less than 1, because this can be represents this. Now, I want also emphasize on this statement. And the second statement just as important as the first statement. The first statement is obviously more important because the first statement says, well, this power series represented by 1 over 1 minus x. But only for -1 to 1. Only for -1 to 1. And I'm going to show you how that works is, if today I highlight this, I say summation of 0 to whatever 5 of 1 over x to the n, like this. It looks like this, right? And then we're gonna say 1 over 1 minus x. And this is only the 5th iterations, and it's already pretty accurate between, let's say, it's negative 0.2 to positive 0.2. It's pretty accurate.
Pretty accurate all the way out to 0.5.
Yep. Then you say, okay, well, what if I change to a lot of iterations? Let's say 50. It becomes pretty good. But if you go into 500, hold on. Let's say it's 500 here. It cut off exactly at -1 to +1. Everything else is not the same. Everything else is not the same because, so this power series can only represent by this interval from -1 to 1. So let's go back to what Sepper is asking. The Sepper is asking, can you give me an example? This is a perfect example. It does not work. This power series does not work anything outside -1 to 1. It's only accurate to 100% if you do it to infinite. Only accurate as much as only for -1 to 1. That's it. And the reason that why is because, remember, if r is greater than 1, the series, the power series diverge. The power series diverge, it cannot represent a function. Remember that. That's a very, very important takeaway here. This is a so important takeaway that you know that it's only work from -1 to 1 because power series has a domain you have to obey by. And how do we find that is the key what we're going to study today. Okay, so that just kind of recap everything. Make sure you guys understand. So far, do you guys understand? Only -1 to 1. That's it. Yes.
Is this domain for all the functions or just this one?
That's a great question. Only for this one. Because only this one is a fit to geometric series. And geometric series has some domain where the function can converge and diverge. But only work when the geometric series converge, therefore only work from between -1 to 1. Yes.
Radius convergence or the interval?
From -1 to 1 is the interval of convergence. The radius of convergence is half of that. Because it's just say, this is my interval convergence. This is where I can smack you. If you come near here, I will smack you. Okay? But anything outside than that, I cannot smack you. So this is my interval convergence. But my radius is only in this part. Only from here to here. So radius is only halfway. Does that make sense? Yes, radius versus diameter. Thank you. That was a very good analysis. Is your dad okay?
Yeah, he went to the doctor's yesterday, but like they didn't give him one.
What happened to him?
I think how many things we didn't get an answer. My mom's in video.
Yes.
Really?
We haven't get there yet. Shh. Yes, Rohan? Guys, if somebody has your legitimate question, so
So if you use multiple facts and get like 3 different functions, is that possible?
can you say that again?
Now, if you use multiple facts, you can get like the 2 different tests that converge, and you get like a different,
Multiple what? Multiple?
like convergence tests.
Okay, you only need to do a convergence test, whatever it works. And then we're going to talk about, we don't have to do multiple. We have to do a specific one. We're going to have to do a specific one, which that one is probably the most powerful convergence test. Well, to answer that question, which one is the most powerful convergence test? With all the tests we have learned, which one's the most powerful? Well, yeah, it's a little bit of both. It's not entirely wrong, but it's a little bit both. Which test? Can you guess? Well, Gabby, what Gabby says? What did you say? Ratio test. Yes.
Every time you say that, I hear facial chat.
It only compresses.
All right. So this is an interval of convergence. I'm sorry. Quick time. Where did it go? Why does somebody have control over my mouse?
That's very concerning.
Whoa, do you see that?
Wait, why are you? Oh my god.
Mr. Yang, you're just replaying a video.
Oh,
It must be Mr. Only again. He's replaying a past video.
how do I stop it though?
He's on bro.
Oh.
Yeah, look at me.
Okay, any question about this part? Okay, so what we're gonna do is we're gonna talk about what happened next. Yeah, I have a lot of I have the reason why I was not here yesterday is because I had a back spasm and I cannot even I was on the floor for and the nighttime I can't even I can't even move. I can't even put my pants on. That's how bad it is. My wife had to help me put my pants on. That's how bad it is. I can't even bend down. And the reason why is because I was coughing so much and I coughed to where my back gave up. And so if I'm talking, please just be quiet because I don't have energy to answer or tell you to shut up because I don't have energy to do that. I basically dragged myself here today because my wife's like, "Why are you crazy? Why you are here?" I say I have to teach a 2-hour lesson. I had to be here. So you guys gotta understand that when I'm talking, I don't have to tell you to be quiet. You guys are not kindergartens. You guys are senior and supposed to be one of the smartest kids in the class. So please make sure I understand that because we need to make sure you understand that. Because I don't have energy to talk out loud. If I talk out loud, I'm gonna cough a lot. If I cough a lot, my back is gonna give out again. Okay. So yes.
For the geometric series one, it's like guaranteed if one situation happens, it's average. If one situation happens, it's like converge. For some of the other ones, which it doesn't completely guarantee if it's converge or diverge, you have to do another test. Does the power series work for them too?
Yeah, well, so what we're gonna do is we're gonna go do a other test. We're gonna do a ratio test for all the situation to find out which interval are they converge. Because not, I'm gonna seriously gonna kick a lot of people out of this classroom. I don't give a shit about you. I just say when I'm talking, if you have a question, you raise your hand, you ask me questions. And the biggest problem right now I have is juniors. I already break up one, and I'll break all you 4 of you guys to 4 separate parts. Or you can be outside the classroom. What I mean junior is not right now. It's not including Lucia, Alejandra, and Christian right now because I moved his seat. So we're gonna say it for a general power series. Summation of n equal to 0 to infinity a to the n of x minus c to the n. So now what we're gonna say the domain of f of x will always be an interval.
What's that word after for symmetrical?
Always for general power series of a summation of n equal to 0 infinity a n of x minus c to the n. The domain of x is always be an interval with x equal to c at the center Now we got three situations here. One is a boring situation, which is situation A. Only work at x equal to c, which is pretty much useless. But it'll only work one point. It doesn't work with any other points.
That's
Only
X
work,
minus C in the equation set, right?
yeah. If a c is a center. Only r equal to 0 here, because there's no radius. Only work one point. It does not work at any other point. So this power series is pretty much like boring. But sometimes it can happen. Only work at one point can represent that function. It does not work anywhere else.
Does it say r equals 0?
R equal to 0, yes. The second situation, which is that we have talked about, is like a sine situation. The sine situation has work from negative infinity to infinity. Long as you do it to infinity, then you'll get 100% accuracy. So this is also a boring situation. That here r is equal to what? What is r equal to? Infinity, good. Because even though it's half of infinity, still from negative infinity to positive infinity, your radius is just infinity. So r equal to infinity. Now this is a boring situation again. C. X minus c is less than r. Where x minus c is greater than r is diverge. So very, very important that you know x minus c greater than r is diverge, but x minus c is less than r. We're going to talk about that. Just let me finish. R is a radius of convergence. X minus c is less than r, is where the radius is. So you can have minus r less than x minus c is less than r. And if you solve for x, then you're going to get x equal to c minus r, less than that, less than c plus r. The range is going to be c minus r and c plus r. Now, I know this is confusing. I'm going to explain that in a second. I'm going to explain it in the diagram. Depends on where my center is, right? My center could be at 5. Right? If my center at 5, my radius is 3, so we'll be interval. If a center is at 5 and radius is equal to, let's say, 3, what's my interval? We're going to figure that out.
2 to 8.
Yeah, it's going to be 2 to 8. So it'll be 2 less than x less than 8. So that is where the interval that's working. That's called interval convergence. So if I find out my radius is, and I find out my center is, I know my intervals. Just like when you're graphing a circle equation, that you had to do that anyway, right? You had to figure out where your center is, you know, what your radius is, and stuff like that. So that's why it's c minus r as on the left bound, and c plus r as the upper bound. The center minus the radius, and center plus the radius. Yes, Supper. We are gonna get to there. I think you keep on asking like what's come up question. I just need you to understand whatever is right now. Yes, Kusham?
For c, it says, isn't meant to be absolute value x minus c is less than r, where absolute value x minus c is greater than r diverges?
Yeah, it's greater than r is diverge. So anything that says is 9 or 10, they all diverge.
So then, in this scenario, what would happen when it's less than r? Like, what does it mean when it's less than r?
It means that's the, so if I says today is my center is x minus 5, right? That's my center, right? and my radius is going to be, so according to this, this is less than 3 and less than it's less than the -3 and 3, right? And if I solve it, if I plus 5 on all of them, that's equal to 2 less than x less than 8. So that'll be the interval that works.
Tells you the range.
Mm-hmm. Any questions so far? Now, what we're gonna do is, we figure out where the radius is, and we can tell you, like, you know, how far it's from working from one side to the other side. But we have to figure out what is the things. So right now, the best test for this is the ratio test. Okay. The reason why it's a ratio test. So instead of geometric series, just like so now I'm start answering people's question. Rohan is asking, do I have to do different tests? No, you only have to do ratio tests because the ratio test is probably the best test. Of all the things, like ratio tests can take care x to the n, right? M factorial, the things that I cannot take derivative of, it's all like easy in terms of ratio tests. So ratio test is the best test to do. Okay, so now, I want to point out something else. The endpoints. The endpoints is really, really crucial. AP exam want to test you the endpoints. Endpoint must test separately. It must test separately. You cannot test the same. Okay. And you're gonna be like, so now the first thing is we're gonna do is this one. Summation of n equal to 0, infinity, m factorial, x to the n. Okay? So I want you to engage in ratio tests.
Every time you say that, I hear something different.
I know, I'm sorry, my pronunciation is not good, but we already gone over that. It's fine. So I want you to try to do a ratio test here. Do you guys realize a ratio test has to be less than what value? It has to be less than 1, right? Same thing like the geometric series R has to be less than 1.
Yeah, it's gonna be weird stuff like story all the time.
Ratio test. I don't want you to do the beginning part of ratio test. So what we're gonna do is limit as n approach infinity of m plus 1 factorial times m plus 1 over m factorial times x to the n. And this is the absolute value of that. And then we will start simplifying. So that's equal to limit n approach infinity of m plus 1 times n factorial times x to the n times x over n factorial x to the n. This is going to cross it out like this nicely. Now remember, there's a difference between n and x. Are we approaching n approaching infinity or x approaching infinity? N approaching infinity. So good. So limits as n approach infinity, absolute value of n plus 1 times the x, right? Now, does n plus 1 has to be inside the absolute value? Why not?
Because we're only applying n plus 1 is what's being the limit.
Because n starts from 1 to infinite, right? So n plus 1 doesn't apply. So limit n plus 1 is n plus 1 to the absolute value of x. So what happens if n approach to infinity? It's gonna be infinity, right? Now that means what x value is gonna give this converge?
Anything besides 0.
Anything besides 0. So therefore, guess what? This only work with x is equal to 0. Only a single point. So it's pretty useless power series, I would say. Because only work on one point, doesn't work on any other point. So in this case, what's radius convergence? R is equal to what? 0. Because there's no radius. So infinity is greater than the 1. If x is equal to any other value, let's say 0.00001 times infinity is still infinity, right?
Yeah.
So only work if it's 0. So therefore, my center is at 0, radius is at 0. There's nothing else I can do. It's just only work on one specific function, one specific location. Yes.
Endpoints must be tested.
We're not getting there yet. You guys keep on asking questions what's ahead. You guys are so fast. I cannot keep a track of everybody, but just be patient. Let me answer all the questions. But if you answer the question, try to answer like what's happening right now rather than later. And I think those are great questions because I'm going to come back to answer those. Yes.
Is the radius just 0 or it is 0?
Radius is 0 because it only work at a single point. Only work when x is equal to 0. It doesn't work when x is equal to something else. Are we okay here? Okay. We're going to ask you to do this one. Summation n equal to 1, infinity, negative 1 to the n of x to the 2n over 2n factorial. Now this one, some of you guys already know what this is. And you probably already know what's interval convergence, but you still have to show me that you can prove it. If you don't know, I want you to think about it, what this one is. Okay? The ratio test is kind of hard on this because you don't understand how to simplify the factorial. But I want you to think about it too. How do I simplify a factorial? Like 2n factorial, right? Think about what's the idea of factorial. Factorial is like, is 5 factorial is 5 times 4 times 3 times 2 times 1. Now this one's a little bit harder because I want you guys to try it first. You might fail at this because the simplifying factorial might be a little bit more complex. Okay, so I want you to try it instead of talk it out. By the way, which power series is this? Anybody knows? Cosine. If you do the Taylor series homework I asked you to do, this is one of them. This is sine and cosine and e to the x, and there's one is natural log. Okay, so now let's try it. So infinity is limit as n approach infinity of -1 to the n plus 1 over x to the 2n. Be careful. This is n plus 1, right? Did you do that? Okay. Over 2 times n plus 1 factorial. Did you guys do that? All over -1 to the n, x to the 2n over 2n factorial. Now, the problem here is if you do absolute value, everything's going to simplify, especially the -1. And here we're going to rewrite as limit n approach infinity of x to the 2n plus 2. Now the bottom is going to be 2n plus 2 factorial, right? And I'm going to keep changing flip. It's going to be x to the 2n, and this is 2n factorial. Now, how do I simplify 2n plus 2 factorial to become 2n factorial? Right, 2n plus 2. Every time you reduce by 1, so it'll be 2n plus 1 times 2n. Does that make sense? Does that make sense? So that's what people are going to make mistake on the test. With 2n, it's kind of confusing because it's over 2n plus 2. Good. So imagine that you have a 10. It's 2n. Right? N is 5, right? So it's going to be 2n is going to be 10. And then 10 plus 2 is going to be 12 factorial. And then your next one is going to be 2n plus 1, which is 11 factorial. Does that make sense? And then the next one is 10 factorial, which is n still equal to 5 here. So basically, it's going to be simplified down to limits of n approach infinity. If this one is going to be x to the 2n times x to the 2 over 2n plus 2. If you reduce by 1, it's going to be 2n plus 1 times 2n factorial. And this is 2n factorial over x to the 2n. Am I going too fast? Make sure you write it down, Ian. Your muscle memory is like missing because when it's on a test, you cannot perform. It's because you don't used to write down stuff. Thinking wise, you have no problem. You're thinking wise, you are probably one of the fastest one here, especially in sequence and series. But the problem is writing down is you don't have that muscle memory at all. Am I going too fast here? Let me know if I need to slow down.
Because it's a plus 2 like that, then you just
So it's every time reduced by 1, right? That's how factorial works, right?
a factorial can always basically chop off the highest tier and make a new factorial of one below it.
Yeah. 1 below it, so it'll be 2n plus 2. What's 1 below it?
2n plus 1.
And then 2n, right?
So it's just the
Yeah, you can even simplify further. You can say 2n minus 1, 2n minus 2, 2n minus 3, right? So this one's going to simplify like this. This one simplified like this. Now be careful here, last part. It says limits as n approach infinity of 1 over 2n plus 2. Wait, what is the absolute value sign? 2n plus, what is it? Uh, 2n factorial cancel out. X to 2n. So it's x squared on the numerator. Yeah, I'm gonna get that there later. Times x squared, right? Now what happened is we know this part is always positive because according to the n star 1 to the go to infinite is never negative, so we don't have to worry about that part. It'd be n approaching infinity of 1 over 2n plus 2 times 2n plus 1, right? Now, x squared is also always positive, so we don't need absolute value anymore. X squared can go away. Absolute value can go away now. Am I going too fast? What happened here? This is going to what? This is going what? This one's going to 0, right? So if this one goes 0, x squared could be anything. Yeah. X could be anything. X could be infinity, but 0 times infinity is 0. So x could be anything. So therefore, your interval convergency is what? What's my radius? Yeah.
Should have went to the bathroom.
It's 3a. If I just like don't take out the x squared, I just say like the whole thing is 0. Actually, that like the whole, I would say like you separated the x squared from 1 over.
Kushang? He has a question.
When you separate the x squared as the 2n plus 2, 1 over 2n plus 2, 2n plus 1, can I just not separate it and just say that like that equals to 0?
I separate them because a lot of people, like for me, like when I was first in teaching, is I also has some issues that got confused as I'm approaching what is approaching to infinity. I separate them so I can just focus on n and then think about x later because that's easier for me. You can do, long as you can get it right, I don't really care, but I focus on just this part. If I'm gonna teach everybody, I want to make sure everyone understand. Is I only focus on the n approaching infinity and I only pay attention on the n. So I put this separately here so that I know what x can equal to. Because I know the first part has to be 0. No, there's no way to find center if you got negative infinity to infinity. I mean, it doesn't really matter because it's working all the way through, right? It'll only work on the specific situation. So what happened here? This is work with negative infinity to infinity, but we know some people already mentioned this is a cosine graph. And we mentioned that cosine graph work from negative infinity to infinity, which is no fun, right? So we're gonna do the one that has different radius. Okay, this one's slightly easier. Summation of n equal to 1. I think previous one's kind of hard.
Wait. No. When we say the interval of convergence, does it apply for like having the parentheses like this or like a bracket?
We are going to talk about endpoints because this part is the endpoint.
One.
You can put a question mark right now. All right, so what we're gonna do is we're gonna do this one, but we also mentioned like Lucia is actually kind of ahead of the curve. It's like, what about the endpoints? And you say that endpoint must test it separately before. And can you get a door for her? So the endpoint must separately before. But do you guys find radius convergence here first? Do you find it? What's radius convergence here? Is what? Somebody say something over there. What's the radius convergence here? Nobody know? Somebody say something? One. Who says one? Okay. So one is correct because x to the n plus 1 over n plus 1. And this one is going to be x to the n n times n x to the n, right? Is limits as n approach infinity. So limits n approach infinity will be the x to the n times x over n plus 1 times n over x to the n. Then this will cancel out. Ian, are you following me? Do you write it down? Okay, good. Because you don't write it down, you don't have muscle memory. Again, the problem is not your understanding. The problem is you don't have muscle memory. What did you did the whole period? So therefore, it's n over n plus 1. So this part is that, okay. So this is why I put absolute value only on x. Because it's easier to analyze now. So separate, to answer your question, now I can just focus on n and x separately. If I focus on n separately, what happened? This one's always going to be what? 1. And we say this has to be less than 1, right? So it'd be absolute value x less than 1. Because this one's less than 1, it doesn't matter what I plug in. The x could be any number, right? If you look at here, less than 1 only work when x is equal to 0. Why is that less than 1? It's very important because now we know that absolute value x can be less than 1. Therefore, absolute value can less than 1 is x is going to be x is between -1 and 1. Yeah, center's at 0. Good. Center at 0. Because there's no x minus c. It's just x. Right? So center has to be at 0. it proved just same as before. There's no difference. Center at 0. Now you're gonna say, wait, what's my radius then? Radius is equal to 1. Vary from 0 to 1 and 0 to -1 is all 1. Just like what Yen's saying, diameter is from -1 to 1. The radius is from 0 to 1, right? Yes.
Okay, you must have like n over n plus 1 is like always gonna be like.
Yeah, eventually it's gonna be roughly a 1. It's gonna go closer to 1 because let's say it's 1 over 2 is half, right? 2 over 3 is 0.66. It's going toward a value, let's say 99 over 100 is 0.99. So let's say 9,999 over 10,000, it's gonna be 0.99999. So it's going closer to 1, but we assume it's 1. Why do we assume it's 1? Because we can divide it by n, divided by n, divided by n, and approach infinity is equal to 1. So we can say this part is just 1. If this part is 1, then I'm just pay attention to the absolute value x less than 1. So absolute value x less than 1, guess what? We find the interval now. The interval is -1 to 1. How many people are confused? Yes. Cannot go over 1 ever. Because you think about 99 over 100. Yeah, we're looking for infinity. We're looking at if we're plugging n equal to infinity.
Like, look, if it was this one, it's under radius is for 5 and 8. So here, set it 0.
We're not there yet. We're not there yet. So shh. So we talk about before the statement that we have mentioned right here. Before we says endpoint must test separately. So what do I do with endpoint? Well, I can plug into the original series. What is my original series? Is summation of n equal to 1, and this is infinity. And original series is we're gonna plug in for -1. This is an x, right? It's not n, right? This is x value. It's not n, so don't plug in the wrong one. So what is a -1 to the n over n? Wait, does that look familiar? What is this? Something harmonic. There's another word before harmonic. Alternating. Harmonic. It's always converge or diverge. We known this before. -1 to the n over n. That's why I need you to go back and redo that test, because that's one of the series. Ian? This is one of the series that we're supposed to know. Alternative harmonic series. How do we prove it? We say, is this alternating? Yes. Is this always the limit n approach infinity of 1 over n? Is that always equal to 0? Yes. Right? And then what's the last one? Decreasing. I mean, n1 plus 1 is less than 1 over n. That's true. Check. So alternative harmonic converge is converge. But wait a minute, let's ask another question. Converge, which kind of converge? Is it absolute converge or conditional converge? It's actually conditional. If I just ask you that one, it's going to be conditional. But for the purpose of converge or not, this is a converge. Is it converge? So we must including -1 less equal to x. Is that okay? Now, what about the other one? How about 1? Summation of n equal to 1 of infinity 1 over n. What is this one? It's diverge. So if you diverge, do we including in the interval of convergence? No. So be -1 to 1 parenthesis. That is the correct answer.
We did that because at point 1 it's inconclusive, right? For a ratio test, when it equals to 1, it's inconclusive.
Yeah, we had to be less than 1. For it to be for sure it's converge. We only care about converge. We don't care about inconclusive. Right now we find out what happened at the end point.
The conditional thing doesn't matter.
Conditional thing does condition doesn't matter because it's converge. But I'll just review a little bit. This is actually not any kind of converge. It's a conditional converge because if you do absolute value, it's 1 over n. 1 over n is harmonic. Harmonic is diverge. So therefore, it's actually just a conditional converge rather than absolute converge. Can I explain what? Because we can equal to -1. We just proved it. Alternative series converge. So we must including -1 because -1 we plug into original series, it converge. It's converged conditionally, but still converge. It still converge. If it converge, can it represent the power series? Yes. So we can including -1 because -1 is part of the point. That's going to be converge. However, if I plug in 1, harmonic. Plug in 1 to where? Right here. Right? You plug in -1 and you plug in here. If it diverge, cannot represent the power series. So the domain has to be including -1 to +1, but not including 1. You guys have enough fun yet?
I have a question.
Yes, please. Thank you so much. You saved my life. I probably break my back. Really?
I have a question.
Yeah.
So we know our value is -1, and if we plug in 1 values and it's converted conditional or absolute, regardless, it's include that value, correct?
Guys, I know you have a question, can answer, and then Lucia can answer.
Making sure.
Give me a second. Yes. What happened?
So I'm just making sure. So if I plug in a value and it comes out absolutely convergent or conditionally convergent, I'm going to include that value.
Yes. A conditional still converge.
And if it's divergent, I'm not going to include that value.
Yes. Okay. All right. You guys can go and help out people. Now, what I'm going to do is I'm going to give you a next question and see what you guys think. I'm going to ask you to do this one. Alejandro, Gabby, what's your question?
We got like from -1 to 1. It's just like, how did you know to go to like the harmonic one and the alternating one? Like, how did you choose those?
Yeah. Okay. So maybe I didn't explain that part. Remember, this is a -1, right? This is x, right? I plug in -1 into the original series,
Oh, okay. I get that.
right? If I plug in the -1 here into the original series, that's why I draw the arrow. This is I plug in the -1 to the original series to see what happened. No, this one just to test the endpoint part.
It looks like a harmonic.
When you plug in the 1 into the
Okay, so this is the next question for you guys to try. Remember, endpoint had to test separately. How much time I have?
Like half an hour.
Good, I have enough time. So I want you to try this one here. Yeah.
Fantastic question.
You can start one. Yeah. No. Katie, give me your phone. Are you serious? What? You don't need a WhatsApp group chat. You need to do the problem on the board. Then work on it. Keep your phone here. God damn. How many of you guys got an answer already?
I mean, I did.
It's a -3 parenthesis 1 parenthesis.
We got the one, not the negative 30.
Yeah, I'm gonna need so.
How many got -1 parenthesis past -3 parenthesis 1?
We got the one. Oh, I see why we need the negative 3. Because in both ways it makes it equal to 1. Yeah. Oh.
Yes, Tupper?
I got one is in.
No. One's diverged. All right. Did you try it first? Okay.
And it got me nowhere.
All right. Shh. So what we're gonna do is we're gonna start from beginning.
Wait, I get it here.
Okay, so I did that.
Any question about this part?
Stop.
This one cancel out this one, left with the x plus 1, right? This 2n cancel with this is 2, right? So this is less than 1, so it'll be x plus 1 over 2 is less than 1. Did you worry about the other side? Did you forget about the other side? Because the whole thing has to be less than 1 in order to converge. And then can I multiply 2 on both sides? Yeah, absolutely, because 2 is positive, so we can take it outside. So it'll be 1/2 of x plus 1 less than 1. And then x plus 1 is less than 2. How'd you get 3?
Yeah.
Okay. Solving this equation is going to be x plus 1 is less than 2, or x plus 1 greater than -2. So x is less than 1, and x is greater than -3. So therefore is -3 and 1. We're going to say question mark on the endpoints. We don't know. So let's go back. We know that it's between those two intervals. So we're going to assume like this right now. We say maybe here, right? Maybe or maybe not. So we don't know what is it. So we can plug in the -3 in there. What happened is summation of n equal to 0. -1 to the n. What happened if we plug in -3? We'll get -2 to the n, right? Over 2 to the n, right? can I break that to separate parts? Can I break that? Sorry, this one is this one's infinity. Can I break that to separate parts? I can. So n equal to 0, infinity, can I break to -1 to the n times 2 to the n over 2 to the n? Does that make sense? Cancel out completely. What is summation of n equal to 0 of infinity -1 to the n? It diverge. Because you adding, first term is 1, -1, +1. So your answer is oscillating between 1 and 0. It's not defined into one value. So therefore, this is diverge. Why is diverge? If you have -1 + 1, -1 + 1, dot, 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 dot. So your answer either can, I'm sorry, you start with +1, right? Sorry, you start with +1. So 1 - 1 + 1 - 1 + 1, dot, 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 dot. Keep on going. Then guess what? What's your final answer? Is it 1 or 0? No, you don't know. Therefore, if you don't know, it's diverged because it's oscillating.
Can you do one?
Yeah, can we put 1, 2? Of course. Yes.
For when you do negative 2 to the n over 2 to the n, where did the original -1 to the n go?
Oh, did I forget -1 to the n? Hold on a second.
Yes.
Let me, it's still gonna be diverged, but let me go back. Did I forget the -1? Okay, -1 to the n. Okay, -1 to the n. Oh, I'm sorry. I did the wrong one. So -1 to the n times this one's a -2 to the n, right? And over what? 2n, right? But can we break it up? This -1 to the n times -1 to the n over 2 to the n over 2 to the n. Is that okay?
Oh, that's
So this one too is going to be always positive. This can cancel out completely. And this one just 2 to the n, 2 to the n, that's equal to 1. I'm sorry. Thank you for, I forgot to put a -1 over in. So it'll be summation of n equal to 0, infinity of summation of 1. What is summation of 1? 1 + 1 + 1 + 1 + 1, dot, 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 dot. Is that diverge or converge? Diverge because you go to infinite. Now let's try the other one. So this is when n equal to -1. It's still diverge because you're just adding 1 infinite amount of time. It's still going to be infinity. Now I'm going to do this one again. I'm going to say n equal to 0, infinity. I'm going to plug in 1. So it'll be -1 to the n to the 2 to the n. Is that okay? Over 2 to the n.
Can you zoom in a little bit? Thank you.
So what happened when n equal to 1? This is what happened. This was summation of n equal to 0, infinity, -1 to the n. And we talk about this oscillation. This start with a 1, -1 + 1, -1. This is diverged because due to oscillation.
so. Just to clarify, this is you explaining why the other one also wasn't diverge.
Yeah, so you got to test -3 and 1.
They're both diverging in different ways.
So therefore, this is true. It's not just a maybe anymore. It's actually a parenthesis -3 to 1. Does that make sense?
I have a question.
Yes.
No, I got.
Okay. Let's look at the right hand side. It's -1 to the n times -1 to the n, yeah?
What? Right hand side, are you talking about n equal to 1?
Yeah, you said the summation goes to 1. Okay, like,
This one should be -3, sorry. N equal to -3. Okay, so what happened?
yeah, for that part, you said -1 to the n, not that
The
one.
negative n equals -3.
Yeah, okay.
This one?
Yeah, so you crossed out -1 to the n and times -1 to the n.
Why do you cross out? Because -1 times -1 is what? 1 to the n is what?
Always.
Yes. So
Can
I
you leave as 1 to the n?
you can leave it as 1 to the n. Does it help you? No. Just get rid of each other.
What was the answer for that?
This one just 1. And summation of 1 is going to be diverged because 1 plus 1 plus 1 plus 1 is go to infinite. Connor, any questions?
Okay, yeah, like if it was 1 to the n, it would still be 1. But that would be
1 to the n is not in fact anything. You can put 1 to the n or not putting 1 to the n. It doesn't affect anything.
okay. So it's just
Because
not
one to the anything is still one that really doesn't impact anything. One is immutable.
It's negligible.
It's both. One will never change.
So I can just leave 1 times 1.
Yeah. If 1 to infinity, I don't even bother to write down.
Mr. Ye says E.
So is your center just -2?
It doesn't
The
matter
center,
how
good
many
job.
times one multiply 1 times 1.
The center is -2? No. The center is actually what? Somebody don't know how to add.
Okay, Mr. Gay.
It's not -1.
It's not -2. She said -2. The center is what?
0?
Radius is from negative.
The center is right here. Look at center. Look at center. This told you the center. -1. All right. Shh. How many people still confused? Raise your hand. Okay. Yes, Ian first and Nina's the first. Ian, go ahead.
They insist that 1 to the power of infinity is e.
No, 1 to the power infinity is not necessary e. If a 1 plus 1 over x to the x, that is e. Okay?
1 to the
If a 1 to the infinity, just 1. So there's a difference between e. E is 1 plus 1 over x to the x. There is small negligible amount of this. This one is going to equal to e, but it's not 1 to the infinity. 1 to the infinity, this still counts 1 to the infinity indetermination in indeterminate form, but it's not it. Because if it's just 1 to the infinity, it doesn't matter. So 1 to the 10 power is what? 1 to the 99 power is what? Does it matter anything? No. It's not e because it's not 1 plus something. But 1 to the infinity is 1 of an indeterminate form. Yes. Because 1 over 1 plus 1 over x, there's a small number right after it to the infinite amount of power is accumulated to become e. Yes, Lena?
So I'm confused about like you only find a quarter to like 1 comma like -3, right? So how will I do the amplify? Like am I just like I was plugging back to the original equation, but what I'm supposed to do like plug in -1 to back to the original.
Yeah, so if you plug in -3 in here, what happened -3 plus 1? That becomes a -2, right? -1 is right here, right? And the 2 to the n's right there, right? And now we just simplify it. Questions? Let's try this again. Try this again. Yep. Yep. So let's rephrase the statement from her. If this represents a function, if this power series represents a function, only represent at the interval of not inclusive -3 to 1. If this represents a function, it doesn't work with anywhere else. It doesn't work with anywhere else. It only work at that. That's called a interval of convergence, and that's only way this can be a power series on that special domain. Well, the key thing is we're looking for the special domain today. Okay, so now this is the next question.
So let's say find a special domain.
You don't have to find out what it converge to, because that the interval convergence is if a summation to infinite, that's going to represent that particular function, only work at this part. If any other domain, then it's going to be diverged. It cannot represent a function. Well, yeah, listen. Okay, that's fine. Next week, what time? I have school that time. Can it be after school? Yeah. Yeah, it's fine. Got it. This is 3, by the way. This is 3, okay? Did you copy wrong? You need to know how to solve inequality. Come on, man. That's like algebra 1.
My mind is superseded that. This. Oh no, it's just negative 1 to 5. It'd be 1 to 3.
You got negative 1. Wait, Krishan, is negative 1 included?
I think it's, I don't think it's included. Yeah.
Maybe.
I think negative 1's included. I believe negative 1's included. Eli, tomorrow, Seminole High School. Actually, do you think you can? Does the Valiant ask you for a ride or no?
Yeah.
Can you give him a ride or no?
Oh wait, you should have it.
8:20.
This is
They're supposed to. Yes.
Now I just put it in.
AB group chat too. Some people are going.
so it doesn't really matter.
Negative 1. So then now you just have that.
Exactly. Well, I'm pretty sure it goes to like a 1 or 3.
Yeah.
All right.
What's actually nice to have
I think you just forgot a square.
Yeah, I'm just gonna find out the bigger.
That's
Well, it's
oh, okay. Thank you.
I plugged them in, but like.
Good.
Yeah.
No way.
How much time I have?
19 minutes.
All right.
15 minutes.
You should get done in 1 more minute. 1 more minute enough?
Well, I feel like I got at least part.
Every group leader check their group members. Alejandra, check Lena. Eli, check Katie.
And then you can pick up.
Am I ready to go?
Let's take this separate. Put this separate. Where does X go? Where's X?
There's no group leaders.
There's X somewhere.
Yeah, you're right.
All right. Every group leader check
Yeah, I
themselves.
just simply forgot to copy it over. I don't know how that happened.
So this one's gonna be x minus 2 to the n plus 1 over n plus 1 square over 3 to the n plus 1 times n squared times 3n over x minus 2 to the n. Is this okay? I'm gonna cross this out. So when I cross this out, I'm gonna get x minus 2. Is that okay? I'm gonna cross out 3 to the n and 3 to the n. That's number 3, right? So what do we have left? N squared over n plus 1 square. And this one is going to be x minus 2 less than 1. Limit n approach infinity. This is to answer. This is to answer back separate question. See, you put it separately, you can see the absolute value only belong here, not the whole thing. It makes less confusing.
Where'd the 3 go?
Oh, 3, yep. Okay, is that okay?
Yeah, I mean, I did that.
So this is 1 because the highest degree is n squared. This part is going to be x minus 2 over 3 less than 1. So it'll be x minus 2 to what? Less than 3. And then you're going to solve for the absolute value. So x minus 2 less than 3. So x is less than what? 5. And then x minus 2 is greater than negative 3. So x is greater than what? Negative 1. So it's negative 1 to 5. We're going to say we don't know what happened at endpoint. Now let's go back to plug in negative 1. So it'll be negative 1 minus 2 to the n over n squared times 3 to the n. That becomes negative 3 to the n. Is that okay? That becomes negative 1 to the n over 3 to the n over 3 to the n squared. Is that okay? I'm going to cross both of them out. This one is P series automatically. I don't mean care about harmonic. This harmonic, this one is going to be converge due to P series. And I'm going to do 5. What happened if I plug in 5? 5 minus 2, summation, n equal to 5, n equal to 0, infinity, 5 minus 2 to the n squared times 3 to the n. This one, summation, n equal to 0, infinity, 3 to the n over 3 to the n squared. Cross it out. P series again. Converge. So therefore is bracket. Yes. Centers are where? Look, centers right here. You can tell from here already. Right? And the center is at 2. Then radius has to be 3. Or you can take this 2 divided by 2. You add together divided by 2. That's going to be your center. And from the center to the endpoint is going to be 3 units. Yes.
I found was that The center is the x minus, and the radius is the one on the other side.
You can take those two, divide by 2 to find center, and from center to the midpoint. It doesn't matter, either way is fine.
On the
Okay, so we're gonna talk about one last thing. One cool thing about power series is this. I'm gonna give you multiple practice questions, but you can understand that power series actually can be integral or taken derivative of, which is that can help you find a different power series with different representation. So imagine you know that the power series of, I don't know, 1 over 1 minus x. If I take an integral of that, what will happen? Natural log of 1, negative natural log of 1 minus x. Then I can find a new power series by using integral and derivative. So I'm going to show you what happened here. This is the part that's really cool. This is the sum of every part. So is, hey, what is the derivative or integral of power series? So let's just say if I have an f of x is equal to summation of n equal to 0 to the infinity, an to the x minus c to the n. This is some type of power series. We can just write it out in the first few terms. Right? Now, what happened if I take a derivative of this? What happened to your first term? What's the derivative of this? 1? Are you kidding me? Can you go back to like
0.
before calc AB, please?
Yeah, I got you for sure.
0. Thank you.
Yeah.
Then you can help whatever that girl's name. Don't want to mention that girl's name. Uh-huh. Oh, wow.
Oh my god, that was your design yesterday. David called him out on it yesterday. David comes up and is like, tell me about it. And I was like, oh my god.
See ya.
A1.
Yeah, no, how do a lot of people know?
Because somebody had to walk them down the classroom. Huh. If you don't want me to find out, don't walk them to the classroom. A1 plus, do you know why it's A1? If I distribute it, it's going to be A1x minus A1c, right? But A1c is a constant. So did I take a derivative of A1x? It's going to be A1. Is that okay?
Because x deletes itself from being derived in the constant.
So what happened to this? This chain rule, this is going to be 2a2 of x minus c, right? And this is going to be what? 3a3 times x minus c to the square. Dot, 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 dot. So the derivative is equal to what? Summation of what? What do you think the first thing is? If I take a derivative of this. What's the derivative of this? What's the first term? First term is 0, right? So we gotta switch to n equal to 1 now. Why is n equal to 1? Because the first term doesn't work. Or the 0 term doesn't work. The first term works. The first term's right here. So the first term is gonna be what? Infinity? What happened to this expression here? It's easier than you think. This is 1. N times x, or times a to the n, sorry, n times a to the n times x minus c to the m minus 1. Do you see why? This general power rule, they take a derivative of n, guess what?
If you pull it down once to derive.
Yeah, and let's subtract over 1. The only thing different is the m equal to 1.
Painful to look at. Oh, that hurts.
Okay, now we can also take an integral. We can say, hey, what's the integral of f of x? Right? What's the integral of this term? A0, not x, because the center is don't know, so it's x minus c. Is that okay? What's the integral of this second term?
X minus c squared over 2.
Good job. Plus a2 of x minus c to the third over 3, right? So can we write down this as a power series? N equal to 0. Infinity, what's the first term? A not 0. A to the what? N. X minus c to the what?
It's the exact same as the derivative, but instead of pulling down,
Do you remember power rule?
instead of multiplying.
Do you remember this power rule, x to the n? Or is equal to nx to the n minus 1? Do you remember integration of x to the n?
Plus c, I guess.
X to the n plus 1 over n plus 1. Thank you. Thank you. Thank you. There was a plus c. Shh. There was a plus c. There was a plus c. Yes, I almost forgot a plus c because there is a constant in the back.
That's
Now-
funny, but you don't get the context.
Integral must gain endpoints. Derivative must lost endpoints. It's a good gain one extra endpoint, and the derivative is gonna lost one endpoint.
As fun to change derivative, the fact.
Okay, so let me finish this part. I cannot answer any more question now. So, hey, I want to find the power series. Can I find the power series of natural log of 1 minus x? Can I find a power series of that? What's a function that has a derivative or integral of this is gonna be natural log 1 of x? 1 over 1 what? No.
1 minus x.
1 over 1 minus x. Good. So do you realize that integration of 1 over 1 minus x is equal to negative natural log of 1 minus x? Do you realize that? Plus c? Do you realize that? Okay. But do you know that integration of 1 over 1 minus x is also equal to what? 1 plus x squared plus x to the third plus x to the fourth. Which just means this one, this is 1 over 1 plus x, right? Now, what happens if I integrate both sides? If I integrate this, this one's going to be negative natural log of 1 minus x, right? We're going to worry about plus c on the right side. So what happened to integration of 1? X. What's the integration of x? X squared over 2. What's the integration of the next one?
So then it becomes.
Now, we're not done yet because we are looking for this, right? So what do I need to do? What do I need to do? I need to multiply both sides by. So it's going to be negative 1 times this, right?
Method of an awful
If you put a series of -1 x, so x to the n over n.
So the power series of natural log of 1 minus x is n equal to 1, infinity, x to the n over n times negative sign in the front. And only work -1 and 1.
Yeah, what do we do with c?
No, I haven't plugged in. Yeah, I don't.
See, we're gonna plug in a value. Plug in 0. What happened? We're gonna use 0 because 0 we know the value. We know the outcome. So what happened if you plug in the that x equal to be 0 at this point? So let x equal to be 0. So what happened if I plug in 0 in this point? It's natural log of 0. This is a plus c, right? What happened to this is all 0, right? So c must equal to what? 0. There you go. This one is the natural log of 1 minus x.
If it's not zero, it lasts up to equal.
Take it outside. Eat. I don't care about you. Eat it. Just take it outside. Take it outside and eat it. Outside. Outside. Outside.
I'm gonna eat it outside. I just can also use it to demonstrate the fabric of reality turning at relativistic distances.
Outside.
No, that doesn't require eating it.
Take it outside to eat it.
I will do that. I also really want to take a picture of this so that I have to touch next year.
What? Oh, shh. Hey, guys. He's asking a good question. How do I know it's -1 to 1? Because the geometric series of 1 over 1 minus x only apply from -1 to 1. So does the integral as well.
Hey, can you say that one more time?
Remember the 1 over 1 minus x? That's geometric series. Only apply between -1 to 1. So therefore, this is also between -1 to 1.
I don't understand it. Okay, first previous question, like at the beginning of the lesson, I didn't understand, but after that, I totally understand.
Yeah, sometimes you guys just don't be patient and